Hi, I'm Madison Clinton, and today we'll be talking about using calculus and physics. Here are the directions for the project. It's pretty self-explanatory. You take a video of all of the calculations from the worksheet that was given. Here is my work. There's the scenario, question 1, and all of the steps that I've taken. And I will go into depth about all of these questions that were given. The scenario that was given was you're leaving school and we need to figure out the distances and the velocity and acceleration of all of the actions. We are going to start with question 1. St equals t3 minus 8t power 2 plus 16t plus 5. And the interval is 0 less than or equal to t and less than or equal to 5. The steps that we are going to take is A, find and interpret S0 and S5. And the next step, is find the maximum and minimum distances from home. It took me a second to get all of this together. When we move on to the question C, finding the intervals, we were moving toward home and away from home. That would be question C. We will show these intervals on the graph at the end. So, question A, S0 and S5, we are going to plug that into the given equation in just a second. I will show those steps. So the first step is writing out the equation, and we are about to plug in each 0 for each power and t place. So we're going to plug 0 for each t, and then we're going to solve, simplify. So I put every step, even though z to the power of 3 is 0, and 8 times 0 to the power of 2 is 0, and 16 times 0 is 0. So S0 equals 5. That is our first value. We are simplifying using PEMDAS. And so here's our second value, S5, T3 minus 8 to the second power, plus 16 to T plus 5. I'm plugging in 5. And we get to 125 minus 200 plus 80 plus 5. It'll be negative 75 plus 80 plus 5, which is negative 5 plus 5, and that equals 10. So S5 equals 10. And that is simply at t hours, 0 hours, you go 5 miles. At 5 hours, you go 10 miles. now we are going to move on to question B. What were the maximum and minimum distances you were away from home, and when did it occur? Again, I will show this on the graph at the very end. Step 1 is to find the derivative of the function. We will do the derivative of t3 plus the derivative of negative 8t2 plus the derivative of 16t, and last but not least, the derivative of 5. This will equal to 3t to the power of 2 minus 16t plus 16 plus 0. And the derivative of the original equation is 3t squared minus 16t plus 16. This is the first derivative of the original function. Step 2 is use the quadratic equation to find the critical points, or the minimum and maximum of the graph. So you plug in the derivative of the original equation, and that would be 16 plus or minus the square root of negative 16 to the power of 2 minus 4 times 3 times 16 in parentheses and all that over 2 times 3, which is 6. Then you solve the numerator and put it over the denominator at the end, and the first plus is 4. And I messed up here a little bit. And then the subtraction part is 4 over 3. Step 3 is plugging in each t values every hour you took to travel. So you would plug in these critical points into either the derivative or the original, and you get the same answers for whatever equation you use. So you, like in the video shown, I used the original equation. I found it easier for some weird reason. The first t value that I'm going to use is 4 over 3, which I chose to do the hardest one first. It's a lot of fractions and a lot of finding the common denominators. So if you do the math, it's 64 over 27 minus 128 over 9 plus 64 over 3 plus 5. And the common denominator is 27. So I lessened all of the steps and just multiplied everything by what the common denominator would need to be. And so I multiplied 128 times 3 to get the denominator to 27, and 64 over 3 times 9 to get to 27, and 5 over 1 times 27 to get the denominator as 27, so we can have a common denominator and make our math easier. Then I subtracted 64 minus 384, and I got negative 320 over 27. And so I finished getting the numerator completely subtracted, added, and everything, so we can get to the final answer of 391 over 27. And that is the first value. The second value I'm going to put in is 4. And we will have 4 cubed minus 8, 4 squared plus 16, 4 plus 5. And we will, at the end, get S4 is equal to 5. It's all about simplifying and using PEMDAS. This is our second value. And so you see I'm putting the values next to the original values so that we can keep track. We already did 0 and 5, so I did the math once more so that we can give everybody a chance to remember what it is. But S0 is equal to 5, and that will be our third value. So now we are going to do 5, S5, and we already know the value for this, so it didn't take me very long to solve it. But again, I'm going to show you the math just so that it's a little bit of a refresher. So S5 is our fourth value, and it is equal to 10. So our maximum and minimum is 4 over 3 to 391 over 27, which is equivalent to 1.333 and 14.481. And our minimum is 4 5 and 0 5. And interesting fact, the total mileage traveled is 24 miles. So we are moving on to C, the intervals. The intervals are pretty self-explanatory. You can either do the traditional way of making the equation equal to 0, and you can find the intervals, or you can look in the graph and find that 0 to 4 over 3 is one interval, and then 4 to 5 is another interval. And then you have, that's moving toward home, and then you have moving away from home, which is 4 over 3 and 4. You can either use the equation equal to 0 or find each interval in between points, which is represented in the graph, and I explained at the bottom. So we are going to move on to question 2. Use derivative rules to find the velocity function vt is equal to the derivative of st. So since we already found it, it's pretty easy. It's 3t squared minus 16t plus 16. And I will show a miniature graph of what it would look like on a graph. And I'll even have the x and y values. And so I put a little note on here that says we found this equation in question 1, part B, because we did. It was the first step to finding the maximum and minimum distances. And so here's me drawing a graph. It hit point 16, 1 through 3, 3 through -5, and 5, 11. And I will show that on the graph in just a second. So I'm going to give myself some time. So I'm going to mark the points. Again, I already said the points, but 1 and 3, 3 and -5, 0 and 16, and 5, 11. Here are all of the x and y values that the graph hits. Again, 1 and 3, 2 and -4, 8/3, and -16/3, which is, by the way, the vertex. And 8/3 is the axis of symmetry. And then you get 4, 0, and 5, 11. Question B is find and interpret V1 and V3, graph and explain. So we did this in step 3 of part B on question 1. So we are plugging in the 1 for each t value and solving. And so V1 is equal to 3. And then we are going to plug in V3 for the t values of the derivative of the first equation. And so it'll be 3 times 9 minus 16 times 3 plus 16. So that'll be 27 minus 48 plus 16, which is 27 minus 32. And that comes to V3 equals -5. Based on the information given, it would take 1 hour to travel 3 miles and 3 hours to go -5 miles. Question C. As you trace the velocity function with your finger or pointer, describe the velocity and its changes from 0 to 5 seconds. In this case, I believe that the velocity is continuous because she doesn't actually stop. She goes from point A to point B, even with the confusion because she's dehydrated and tired. She doesn't ever stop, so the velocity doesn't stop. So question 3 is use derivative rules to find the acceleration function at equals b. T, the derivative vt equals the second derivative of st. Acceleration is the derivative of the velocity function, and that is the same as the derivative of the second derivative of the original st function. So we are going to get the derivative of 3t squared plus the derivative of -16t plus the derivative of 16. And that will come out to 6t plus minus 16 plus 0, which acceleration is equal to 6t minus 16. Yeah. And so there's my work. You'll see that really close in person. And those are the zeros, and I will get to that in just a second. So here's a small video of me plugging in all of the points into the graph so you can have a visual of what all 3 points on one graph would look like. And I will include the zeros. So here's me plugging in the velocity function. And here is the acceleration function. And that is the final product. And so I'm going to go through the zeros real quick. So the first zero is -0.2740, and that's the zero of the st original function. Here is the velocity zeros, and here is the acceleration zeros. Thank you.